I am presenting joint work with Dennis Campbell, David Freeberg, and George Serafine, who are all at Harvard, on science-based carbon emissions targets. The Paris Climate Agreement in 2015 saw nearly 200 countries commit to limiting global warming. This international agreement signaled to the business community an acceleration in the transition to what we call a low-carbon economy. As a result, lowering carbon emissions has become increasingly important for companies, of which over 6,000 set carbon reduction targets in 2018, according to data from the Carbon Disclosure Project. Recently, a best-in-class standard for setting carbon reduction targets was developed to align targets with what climate science says is required to limit global warming. While a number of firms have voluntarily adopted these standards to confer legitimacy onto their carbon reduction efforts, it is unclear whether and how these standards influence target setting and target achievement. So in this paper, we examine whether the emergence of a standard that assesses if a firm's carbon reduction target is aligned with climate science affects the difficulty of that target and efforts to reduce carbon emissions. Targets adopted by companies to reduce carbon emissions are considered science-based if they are in line with the level of decarbonization required to keep global warming or global temperature increases below 2 degrees Celsius compared to pre-industrial temperatures, as described in the 5th assessment report of the Intergovernmental Panel on Climate Change. By the end of 2019, nearly 900 companies had already released or committed to release science-based targets using standards developed by the Science Based Targets Initiative, or SBTI. As a way of background, the SBTI is a not-for-profit organization that assesses whether carbon targets are science-aligned and approves and certifies those that are. While the Science-Based Target Initiative provides tools that help companies set targets that are aligned with climate science, it does not actually help companies reduce their emissions, nor does it advise them on how they can achieve their science-based targets. So to set a science-based target, a company must first sign a commitment letter indicating its intention to set a science-based target. After signing the letter, the company has up to 2 years to submit targets for validation, and if they are approved, the firm will be showcased on the SBTI website, and the firm can promote the SBT logo and the fact that they have a science-based target. And if not, the company has 6 months to resubmit, otherwise they will be removed from that commitment letter. Our first question is why do firms choose to adopt science standards for their targets as opposed to keeping their targets aligned with their internal standards, or the traditional approach that they had to set their targets? On the one hand, aligning carbon targets with climate science and receiving certification from the SBTI could add legitimacy to firms' climate change efforts. It's also possible that setting these science-based targets helps a company manage its own climate change-related risks and may help the company capitalize on opportunities to innovate in order to achieve more ambitious reductions in emissions, which could potentially lead to new products that even help other companies reduce their carbon footprint. This leads to our first prediction, that the likelihood of adopting a science-based target is increasing in the risks and opportunities from climate change faced by the firm. However, prior to these external standards having been developed by the SBTI, companies had already spent considerable time and effort setting targets using their internal standards. For instance, basing targets on what industry peers were doing or on prior year carbon performance. Changing targets can be time consuming and face a lot of pushback from those in the organization that already had a plan to achieve legacy targets. There's also the issue of allocating decision and control rights over targets to the external standard setting organization, in this case, the SBTI. And standards change over time to reflect advances in scientific modeling and climate science. Companies risk losing control over the target setting process and committing to targets that may be suboptimal or unattainable. So given these risks, our prediction is that Firms with a track record of setting difficult targets and of actually successfully completing their targets will perceive lower risk from adopting the standards, leading them to be more likely to do so. We are also interested in whether science-based targets are more ambitious or difficult relative to non-science-based targets. The SBTi's intention is for science-based targets to accelerate carbon reductions, but if firms only adopt the external standards when they know their existing targets are already aligned with the standards, companies could get certification and not have to increase target difficulty. Another possibility stems from how difficult it is actually in practice to set optimal targets, which are at that tough but achievable threshold. And that's like the standard prescription from the vast prior literature on target setting. So if firms have uncertainty regarding whether or not they are setting optimal carbon targets and external standards help to resolve this uncertainty, they may be more likely to set more difficult targets. Like this quote suggests, science-based targets are grounded in science. They provide companies with information about what constitutes a credible and rigorous target. So if companies learn that their existing targets fall short of these science-based standards, they may align their targets with those standards, which we call adopting through learning. This leads to our second hypothesis that adopting science-based standards increases the difficulty of firms' carbon reduction targets. To test our hypotheses, we use data from the Carbon Disclosure Project. CDP, as many of you know and use this data, it's an international not-for-profit organization that provides a framework for companies to report information on their environmental outcomes. The annual investor survey of the CDP requests climate change information from the world's largest companies by market capitalization on behalf of institutional investor signatories. The survey has over 200 questions, and we focus on responses to 3 sets of questions. The first set of questions pertains to carbon reduction targets. The second set of questions asks managers to assess the risks and opportunities to their business driven by climate change. And the third set of questions asks managers information about projects, investments, and initiatives that they undertake to reduce emissions. To assess the determinants of adopting science-based targets, we first construct a data set of firms that set carbon targets. Okay, so all of the firms in our sample do set carbon targets, and then we examine within those firms which ones are more likely to adopt external science-based standards to set their targets rather than continue to use internal standards to set their targets. Our dependent variable is science adoption, an indicator equal to 1 if the firm adopted a science-based target in 2016 or 2017, and 0 if the firm did not adopt science standards for any of its targets. 22% of the firms in our sample have adopted a science-based target. Past target setting behavior is modeled by target ambition and past target completed. We measure target ambition as target difficulty divided by the horizon, the time length of that target, multiplied by coverage, meaning how much of the base emissions are covered by the target for all prior targets set by the firm leading up to 2016. Past target completed is an indicator that takes the value of 1 if the firm has in the past successfully completed a carbon reduction target. 77% of the firms in our sample have done so. We predict that both of these variables will be positively associated with a firm's decision to adopt a science-based target. Economic incentives to address climate change are measured using low carbon revenue and emissions over sales, where low carbon revenue is the percent of a firm's revenue from low carbon products, and emissions over sales represents carbon intensity. Future risks may also affect decisions to adopt science-based targets. We have likelihood risks, timeframe risks, and magnitude risks, which measure managers' assessments of the risks to their business driven by climate change, also from the CDP. This table presents the results of our determinants model. The odds ratio on target ambition and past target completed is in excess of 1, suggesting that both of these factors increase the likelihood of adopting a science-based target rather than keeping your target aligned with your internal standards. We dial up target ambition from its mean to a standard deviation above its mean. This is associated with a 23% greater likelihood of adopting a science-based target. For otherwise average companies, the predicted probability of adopting a science-based target is 28% higher for firms that successfully completed a target. Higher revenues from low carbon products also increases the likelihood of adopting a science-based target, but we don't find that carbon intensity plays a role. And finally, companies perceiving a greater likelihood of and magnitude of impact from climate change risks to their business are more likely to adopt science-based targets. So overall, the results suggest that past target setting behavior, as well as economic incentives to reduce their emissions, predicts which firms will adopt these science-based targets. Moving on to our second hypothesis, we create a target level panel data set because the firms in our sample set multiple carbon reduction targets, right, which differ by scope and coverage, so that conducting analysis at the target level allows us to follow a specific carbon target through the adoption or non-adoption of those science-based standards. And so to identify changes in target difficulty associated with adopting those science-based standards, we regress target difficulty on science target, an indicator equal to 1 in the year that a target becomes aligned with the science standards, and every year thereafter, and 0 if that target does not become aligned with science standards. And we have here our results. The coefficient estimates showed us that target difficulty increases between 19% and 26% after a target becomes aligned with science standards. Although we do include a robust set of fixed effects as well as time-varying financial and target level controls, there could still be differences across adopting and non-adopting firms, right, that bias the coefficients. So to help address this, we use propensity scores to match firms that adopt science-based targets and firms that do not adopt science-based targets, and we find that the full sample results are supported using this match sample. So taken together, these results are consistent with targets becoming more difficult after the adoption of the science standards, which is more in line with the adopting from learning explanation as opposed to firms adopting the label. So even though the targets appear to become more difficult after adopting science standards, this could just be cheap talk, right, in terms of just wanting to adopt standards, actually show a more difficult target, but not actually intending on achieving those targets. Although right now it's a bit too early to tell whether companies achieve their science-based targets because the average horizon of the target in our sample is 10 years, we can assess whether and how their climate change initiatives may change following the adoption of science standards. To do this, we create a firm-level panel data set that contains data on firms' climate change initiatives over the years 2011 to 2007. So in terms of the adopting and non-adopting firms, we find that the climate change initiatives for science firms have approximately 61% more investment required, 18% greater CO2 savings, which of course are estimated by the firm, 61% higher monetary savings. And after adopting science-based targets, climate change initiatives of the firm become, they spend more money on them, and they also anticipate greater CO2 savings, and the payback period of those initiatives also goes up. We find that that's not being driven by a target difficulty entirely. So we can talk a bit more about that in the breakout session or the Q&A. So in this paper, we look at why firms adopt external standards for their targets rather than just keeping their targets aligned with their traditional approaches, and how the adoption of the external science standards relates to target difficulty and efforts to reduce carbon emissions. We look at the determinants. We find that those targets become more difficult once they adopt the science standards, and this doesn't appear to be cheap talk. But of course, a limitation of our study is it's too early right now to really look at the impact of the SBTI on overall corporate carbon emissions. And so we present that as a great opportunity for future research. Thank you very much.